NFPA 110, the standard for emergency and standby power systems, includes Annex A, which offers guidance on Level 1 and Level 2 emergency power supply systems. Finding comprehensive information without purchasing the full NFPA document can be achieved through several online resources. The NFPA's website itself is a good starting point. It may provide access to Annex or related information. Additionally, various online platforms dedicated to electrical engineering and safety often host articles, summaries, or discussions pertaining to NFPA 110 and its annexes. The Electrical Engineering Portal is a website that provides resources such as the NFPA 110 Annex A. Another online source is the Governor's Emergency Plan Library, which may contain documents or excerpts related to NFPA 110 Annex in the context of emergency preparedness and resilience planning. NFPA Today might also feature articles or news items that touch upon Annex of NFPA 110, highlighting key safety considerations. Manufacturing facility design may present information about NFPA 110 Annex A, particularly focusing on the electrical design aspects of manufacturing facilities. While these resources can be valuable for gaining insights into NFPA 110 Annex A, it is important to acknowledge that the information they provide may be limited in scope or potentially outdated compared to the official NFPA document. The NFPA continuously updates its standards to reflect the latest technological advancements, best practices, and safety requirements. Therefore, relying solely on online summaries or excerpts may not provide a complete or fully accurate understanding of the current guidelines. For the most precise, complete, and up-to-date information, consulting the latest edition of NFPA 110 is crucial. This ensures compliance with the most recent regulations and promotes the highest level of safety in emergency and standby power systems. Level 1 emergency power supply systems are designed to provide power automatically and without interruption upon failure of the normal power source. These systems are essential for critical applications where any disruption of power could have significant consequences, such as light safety systems in hospitals, emergency lighting in buildings, and critical processes in industrial facilities. Level 2 emergency power supply systems also provide power automatically upon failure of the normal power source, but they may have a slightly longer transfer time compared to Level 1 systems. Level 2 systems are typically used in applications where a brief interruption of power is acceptable, such as general lighting in commercial buildings, non-critical equipment in industrial facilities, and some types of communication systems. Annex of NFPA 110 provides detailed guidelines for the design, installation, testing, and maintenance of both Level 1 and Level 2 emergency power supply systems. It covers various aspects, including the selection of appropriate power sources, the design of transfer switches, the sizing of generators, and the implementation of monitoring and control systems. The Annex also addresses specific requirements for different types of facilities and applications, ensuring that emergency power systems are tailored to meet the unique needs of each situation. In addition to the specific requirements outlined in Annex A, NFPA 110 also references other relevant standards and codes such as the National Electrical Code, or NEC, and the National Fire Alarm and Signaling Code, NFPA 72. These references ensure that emergency power systems are designed and installed in accordance with all applicable regulations and best practices. The design of an emergency power system involves several key considerations, including the load requirements of the facility, the available space for equipment, the environmental conditions, and the budget. It is important to carefully assess these factors to select the appropriate power source, transfer switch, and other components. The power source for an emergency power system can be a generator, a battery system, or an uninterruptible power supply, UPS. Generators are the most common type of power source for larger facilities, as they can provide a reliable and continuous supply of power for extended periods. Battery systems are typically used for smaller facilities or for applications where a short-term power outage is expected. UPS systems provide instantaneous power during a power outage, but they have a limited capacity and are typically used to protect sensitive electronic equipment. The transfer switch is a critical component of an emergency power system, as it automatically switches the load from the normal power source to the emergency power source when a power outage occurs. Transfer switches are available in various configurations, including automatic transfer switches (ATS) and manual transfer switches. Automatic transfer switches are preferred for critical applications, as they provide seamless transfer of power without any manual intervention. The installation of an emergency power system must be performed by qualified and experienced personnel in accordance with all applicable codes and standards. It is important to ensure that all components are properly installed and connected and that the system is tested thoroughly before being placed into service. The testing of an emergency power system is essential to verify that it will perform as intended during a power outage. Testing should be performed periodically, typically on a monthly or quarterly basis, to ensure that all components are functioning properly. The testing procedure should include simulating a power outage and verifying that the transfer switch operates correctly and that the emergency power source provides power to the load. The maintenance of an emergency power system is crucial to ensure its continued reliability and performance. Maintenance should be performed on a regular basis, typically on an annual basis, to inspect all components, lubricate moving parts, and replace any worn or damaged parts. The maintenance procedure should also include testing the system to verify that it is still functioning properly. NFPA 110 also addresses the requirements for remote annunciation of the EPS status. The EPS, or Emergency Power Supply, status should be annunciated remotely to allow for monitoring of the system from a central location. This remote annunciation should include information on the availability of the EPS, its operating status, and any alarm conditions. The remote annunciation system should be designed to provide reliable and timely information to the monitoring personnel. The location of the EPS should be carefully considered to minimize the risk of damage or disruption. The EPS should be located in a secure area that is protected from fire, flood, and other hazards. The EPS should also be located in an area that is easily accessible for maintenance and testing. The EPS should be located as close as possible to the loads that it serves to minimize voltage drop and improve system performance. The environmental conditions in the EPS location should be carefully controlled to ensure that the equipment operates within its specified temperature and humidity ranges. The EPS should be protected from excessive heat, cold, humidity, and dust. The EPS location should be well ventilated to prevent the buildup of heat. The size of the EPS should be carefully determined to ensure that it can meet the load requirements of the facility. The EPS should be sized to provide sufficient power to all essential loads, including life safety systems, emergency lighting, and critical equipment. The EPS should also be sized to allow for future expansion of the facility. The EPS should be designed to operate reliably under a variety of conditions, including extreme temperatures, high humidity, and power outages. The EPS should be designed to withstand the stresses of a power outage, such as voltage transients and frequency fluctuations. The EPS should be designed to operate for an extended period without maintenance or refueling. The EPS should be designed to be easily maintained and repaired. The EPS should be designed with readily available spare parts. The EPS should be designed to be easily upgraded or replaced as needed. The EPS should be designed to comply with all applicable codes and standards. The EPS should be designed to be safe for personnel and equipment. The EPS should be designed to be environmentally friendly. The NEC, specifically Article 700, addresses emergency systems. Article 700.3 covers tests and maintenance for emergency systems. According to 700.3, emergency systems shall be tested periodically as follows. Equipment shall be suitable for the intended use and shall be designed and installed so that the intended system performs as intended when the normal source of power fails. The emergency system must function when the normal power fails, and the equipment must be designed for that purpose. For a battery lighting system, at least every month the battery must be checked to make sure it's fully charged and able to supply the power for the required amount of time. The results must be kept in writing for inspection. For a generator set, the generator set must be tested at least monthly under load for a minimum of 30 minutes. This will ensure that the generator will start and operate correctly when needed. A written record of the tests and maintenance must be kept for inspection. Emergency lighting should come on automatically when the normal power supply fails. Emergency systems should be inspected and tested regularly to ensure that they are operating correctly and are ready to provide power when needed. Emergency systems should be tested frequently enough so that problems are detected and corrected before they can cause a failure. Some of the factors that should be considered when determining the frequency of testing include the type of equipment, the environment in which it is operating, and the criticality of the load that it is serving. Emergency systems should be maintained in accordance with the manufacturer's instructions. Maintenance should be performed by qualified personnel who are familiar with the equipment. The requirements for emergency systems can be found in the NEC, as well as NFPA 101 Life Safety Code. The NEC covers the installation and wiring of emergency systems. The Life Safety Code covers the design and operation of emergency systems.